simple regression analysis, confidence interval, and prediction interval. In regression analysis, we have a group of observations, points. We have their coordinates x and y, and we are going to investigate if there is a relationship between x and y. In other terms, if we increase the value of x coordinate, the value of y increases or decreases consistently. Do we have a line that represents the relationship between these two, and then if there's any significant relationship between x and y? If we focus on one observation, there's an actual value of y for that observation, for that point. But then if we have a regression line, there's an estimated value for y. There's a difference between these two values, the real value and estimated value of y at that level of x. We call this difference error. We can also look at overall value of y's. They are represented by the mean of all y's observed. We do have a difference at any point between the estimated y and overall mean, and we call this the difference or deviation due to regression. Least squares method finds the line based on the least sum of squares of error and regression for all points. For all observations, we have errors. We also have deviations from the mean due to regression. And the analysis of these squares will determine the significance of the regression line we find. There are some assumptions for linear regression. Linearity and additivity of the relationship between x and y. It means the relationship is linear, it's not a curve. And if we add the value of x, the value of y will be added consistently, or y will decrease consistently when we add to the value of x. If our data set does not conform this assumption, we need to consider a nonlinear model or do a nonlinear transformation of the predictor x. Next assumption is that errors are statistically independent. There is no relationship between the consecutive errors. Homoscedasticity of errors or homogeneity of variances between errors and predictions y and independent variable x. And we have the assumption of normality of the error distribution. Error distribution is normal. Diagnostic tools are provided in most software packages, including Excel. Call them residual plots, and by observing residual plots we can judge the assumptions if our data set is meeting the assumptions or not. Most observations on these residual plots are based on randomly scattered errors. If there is a specific pattern in errors, then our regression analysis is not valid. We also have normal probability plot. It determines if distribution of errors is normal or not. We also have confidence interval concept. We do have some level of uncertainty when we have an estimation of any population parameter. Any estimate based on a sample has some error, so we need to develop a confidence interval with our estimation. For example, average money a shopper will spend during the holiday season, a number many businesses are interested in knowing. But then with that estimate, we need to estimate the confidence interval within, for example, 95% confidence. That number is between an upper and lower limit. Or percentage of people voting in a federal election or voting for a specific candidate there's always an estimate, and then there should be some upper and lower confidence limits for that estimate. So we do have some confidence in some margin of error for each estimation. For a mean, we do have the population standard deviation. We're looking at the confidence interval around the mean. If our alpha is 5%, that means we consider 5% chance for error. Within the remaining 95% chance, we develop our confidence interval. We don't know our estimate is less than or greater than the value we considered, so we split that 5% into 2.5%, and 2 tails. And the distance from the center to each of those 2.5% areas will be our margin of error. So we use standard error because we have a sample by dividing the standard deviation of the population over the square root of the sample size, and our interval estimate of population mean will be our estimate of the mean plus minus the z-score of the confidence here times the standard error of the sample. If we do not have the standard deviation of the population, we use t-score, and there is a formula for estimating the confidence interval of a regression. This formula is for estimating confidence interval for an average value of y, or response, when we have a certain level of x. Prediction interval for regression is a similar formula with a difference. The difference term is here under the square root. The difference of these two formulas is that in prediction interval, we are estimating the interval for a specific value, for a specific location. For example, if you're estimating average sales for an outlet, when we spend $10,000 on advertising, then we use confidence interval formula. But if you're estimating sales for a specific week, when we spend the same amount of money on advertising, then we have to use prediction interval.